Very excited to spread the joy of Python to others. And today, several awesome helpers who will be, as Lisa mentioned, will be available to if you're having any trouble, and we'll be doing all of that in the Slack channel. So maybe right now, if the helpers are here and are ready, we can just do a quick introduction. Each of you tell us your name. Pronouns. Mine are she, her. So tell us your name, pronouns, and maybe how you like to use Python. So we can go through maybe in the list in our workshop document there. So it starts out with Syed. Did I pronounce that correctly?
Yeah, it's correct. Hi, everybody. I'm actually my name is Mahdi, so that's the prefix. Yeah, I'm Mahdi, and it's a he. And also, I like to use Python in my research interest, which is computer vision and computer graphics. Thank you all.
Thank you. And do we have Matthew Tang? Okay, he doesn't have a mic, so he'll be available on Slack. We will switch now to, we have Socorro Dominguez. And they might not have joined yet, so we can move on to the next.
Socorro in the chat, actually. Or I see her as one of the attendees. So perhaps
okay.
She also has mic issues.
Okay, so if you have mic issues, no worries. We'll all be able to, be able to find everyone in Slack. We have, and please, if I mispronounce anything, please correct me. Madana Krishnan. Okay, is Saghar here?
Yeah, it's actually Saghar. So I'm Saghar, I'm a she. I'm doing my master's in computer science at SFU, and I use Python in my research, which is in computer vision field, and I'm happy to meet you all.
Thanks. And that's everybody I had on the list, but there might be a few others who I might be missing. Are there any other helpers who are here who would like to introduce themselves? Okay, so you'll be able to find everyone in the Slack channel. Now, I'm assuming everybody has access to the Slack channel. It's the beginner, it's called Workshop Beginner Python. So you'll want to just keep that window open on your screen somewhere. I know it gets a little challenging when we're navigating multiple windows. So you'll want to have your Slack window open, and also there's a document that I shared in the Slack channel, and let me switch over to it now, if everybody can see. Do you all have access to this document? If you don't, you can just find it in the Slack channel, and so it'll have all the links and everything that we'll be referring to as we go forward here. And so just a heads up, this is my first time teaching online. We may have a few hiccups here and there, but so bear with us, but hopefully things will go pretty smoothly. And so let me just see. So you'll want to have Slack channel, the Google document. Now, let's talk about how to code along. And we will be we gave you two options to set up your software. One was to use Python online on a site called Syzygy, where you don't need to install anything on your computer, or you could install Python. So what I'm going to do right now is I'm going to put a poll in Slack, and that way we can also test out the poll features. you can just let me know which one you're using, and also if you need any help with setup. If you had any issues trying to get set up, you can let us know there, and a helper can get you sorted. Okay, so if you see in the Slack channel, I've now added a poll. Yes, awesome. People have started replying already. This is great. And so the helpers will, I'll let them keep monitoring here in case anybody needs any help. Okay, cool. Lots of people are installing on their computer. And what I'll do is I'm going to go through both options in terms of getting ourselves set up and launching Python and running Jupyter notebooks. So let me go now to our schedule for the day. So this first session, which will be about 45 minutes, we're going to do an introduction to Jupyter notebooks. And then we'll have about a 15-minute break. And then we'll be using Pandas, an intro to Pandas, which is one of the main libraries for doing data analysis in Python. And then we'll have another 15-minute break, and then we'll do the data visualization, which is going to be really fun, and you'll get to make some pretty cool plots with that. So let's dive in with the intro to Jupyter. Let me just... Okay, so if there's any issues, I'm assuming everybody can see what's shown on my screen right now. It should say, "What is Jupyter?" If not, can you please let me know, post in the Slack channel a message or something to let me know?
Everything is fine. Okay.
Great, thank you. Okay, so we're going to be using Jupyter to run Python, and you can think of the relationship between Jupyter and Python is that Python is like the engine of a car, while Jupyter is like the dashboard. So Python is the programming language that's doing all the computation behind the scenes. And then Jupyter is an integrated development environment, an IDE, that provides an interface, and it adds really convenient features and tools to make life easier. So we'll be doing all our work in Jupyter notebooks, which are a document where you have code, plots, formatted text, equations, all kinds of things in one single document, and you can run your Python code interactively. It also supports a bunch of other languages as well. So let's just see what an example notebook looks like. And it's just taking a moment to load. Okay, so we have this example notebook, and you can see it looks a lot like a regular document where you have various formatted text. And then we also have code where you actually can run the code here and print the output. And you can have, for example, it shows tables in a nicely formatted way and plots as well. So you have all of this in one document, and you can run each snippet of code on its own and see what the output is, and then tweak and iterate over it, which is very handy when you're working with data. So notebooks are really great for exploring the data and also for documenting your workflow and explaining everything you're doing as you go along. And they're also cool because you can share them. It's very easy to share them online. So even if someone doesn't have Python on their computer, they can still look at a notebook that you've posted online and see how you did your calculations. Okay, so we have two options for running the Jupyter notebook, and let me just check in our pool here. Okay, so we have a few people using the both different options. So I'll run through both of them here, and I'll show you how to get started. So let's now look at if you were working online on Syzygy. So you can get the link from the workshop landing page, that document I showed at the beginning, and it should take you to a site that looks like this. And there is a sign-in button on the top right. And if you haven't signed in before, it'll prompt you for your GitHub credentials. Because I've signed in before, it just takes me here automatically. And so hopefully everybody has created a GitHub account if you're using Syzygy. And if you have any trouble logging in or need help with that, you can post in Slack. So this is called the Notebook Dashboard. And this is where we'll be creating our new notebooks and saving our work. And now let me show if you're working on your own computer and you've installed Anaconda, then you'll find a program called Anaconda Navigator. And you can click on this icon here, Jupyter Notebook. And when you click on that, it'll launch and you'll end up in a very similar page as what we saw with Syzygy. Now, in my case, so this goes basically in your home directory of your computer. And if you're not familiar with that, it's basically just the sort of the root of where all of your files are stored. So for me, I have a bunch of different folders. And so you'll want to make sure you know where you saved your work, because wherever we go in here is where it's going to be saved. So for example, I might go to my folder Documents, and if I'm in this Documents folder, which you can see from the top, this is where everything's going to be saved. So you might want to navigate to change what's called your working directory. And you just want to pay attention to what's shown up here on the top so you know where to come back to find the work that we're doing. Okay. So, and I'm just getting a little bit of background noise here. So I wonder if anybody, if you could all just check and make sure you can mute yourself if your mic is still on. And okay, sorry, just looking at the chat to see if there's anything going on. Okay, Lisa, just give me a heads up if I need to pause for anything. Okay, all right. So whether you're working on Syzygy or you're working on your computer locally, what you'll want to do is we're going to create a new notebook that we can use for doing our work for the workshop. And so you can create a folder. So here, if you click New, you can say create a new folder. And it's always defaults to untitled folder. And if I want to rename it, sorry, so now if I want to go back, I accidentally clicked on it. So if I go up here, I can click to the side of it and then say rename. And I'm going to call it Datajam Workshop. You can also just do everything like straight in the, you don't need to create a new folder. You can just do everything in your working directory if you want, but it's usually good to create a folder so you can save everything. So now I click on that and I'm in a folder called Datajam Workshop. And so what I'll want to do is click on New again. And I'm going to create a new notebook and it'll say Python 3. And so now we have a brand new notebook. So we can change the name of it up top. So we click on the top where it said untitled and we can say, well, let's call it Workshop. And if we go back now, we have the previous dashboard window that we were in. You can now see we have this new notebook. And it's called workshop.ipynb. And that stands for Interactive Python Notebook. So this is where everything in this file is where all your work is going to be saved as we get started. Okay. So if we go back to our notebook, then let's try some things. So we're going to, we can just start running code. So print hello world. So this notebook is divided into what's called cells, and you have two main types of cells. One is a code cell, which is what this is, and all new cells are code by default. And you also have markdown cells, which are the text ones. So when you want to run the command, so you click inside the cell and you type your code, and then you press Shift Enter, or you can also click Run from the top menu to run the code. So hello world. I can do 2 + 2. And each time when you run the code, it will create a new cell below where you can do some more work. I can create a variable. So for example, I'm going to say today equals Friday. And I'll create another one, tomorrow equals Saturday. So now these variables are available to me again. So I can say print today, and it'll print it. One of the cool features with Jupyter Notebooks is it has autocomplete. So if I start typing TO and then I press tab, oops, there we go. It'll pop up with a little autocomplete option. So I can say tomorrow. And when you have a cell, and if you just type the name of a variable in it, or an operation like 2 + 2, then it'll display the output when you run this cell if you don't do any other, if you don't have any other code in the cell. Okay, how are we doing so far? Is everybody able to create their new notebook and do a run 2 + 2 or hello world? If there's any issues, please let us know in the Slack channel. We're good? Okay. Sorry, it's very strange presenting to like just a screen without having people there in person. So I'm just getting adjusted. Okay. So in our Jupyter Notebook, we have our code cells, and we can also, we can use, for example, here's my built-in Python function, round 3.14159 to 2 digits, and it rounds that. And if I want to see the documentation for this function or for any function, I can do a question mark at the end of the function name and then Shift Enter, and it actually shows the documentation right there, which is really, really handy. So, and then you just close the little button to to close that window. All right, and then the next type of cell, let's work with a markdown cell. So I have a new cell, it's a code cell by default. If I click on this top toolbar and I select markdown, it'll change to a markdown cell. And so now when I click inside it, this is just regular text. And if I press Shift Enter, it renders it just as regular text. And so now if I want to, let's say I want to edit this, I can go and I click on the cell and it doesn't do anything if I single click, but if I double click, now I can get in there and modify it. So Markdown is really cool. If you haven't used it before, I have a link in the slides, which you can find a link to those in the landing page. So I can do a heading, welcome to the workshop. I can do a smaller heading, schedule, Python is awesome. And I could do things like bulleted lists, and you can do equations, bold, some text in bold, and so on. And so now you have this nicely formatted cell, which you can use to divide your document, for example, into sections. So it's easy to find things and to document your work as you go along. The other thing to know about Jupyter Notebooks is that they're similar to a Google document where it automatically saves quite frequently. But if you ever do want to make sure it's saved, like right now, you can see at the top it says unsaved changes. I can click this save icon, or I can also do Control S or Command S if you're on a Mac, and that will force it to save. Okay, so what happens if I close this window? So now I'm back on my notebook dashboard, and you can see next to the notebook, it actually says running. So when you launch a notebook, it creates a process called a kernel, which is basically that engine of the car in the background that's running Python. And so even if I close the window, it's still running in the background. And you can also see what's running by looking at the, and I have a bunch of other stuff on the go. So we've got a whole bunch of notebooks here that are running. So when you click on the running tab, so if you want to actually shut it down, you can shut it down from here, or I'll show you also in the notebook how you can shut it down. So if I reopen this, and now I say, so I had, remember I had defined variables called today and tomorrow. So if I say print today is today, it actually still remembers the variable today from what we had in before. That's because the kernel is still running. So if I want to actually stop the kernel, stop this background process, which will mean I'll lose all the variables and everything until I open the notebook again and restart the kernel, I can go File, and then Close and Halt. Oh, and it'll prompt me. So now it's telling me, oops, it hasn't saved yet. So let's go cancel and let's save our work. And now File, Close, and Halt. And it no longer says running anymore. So if I open up my notebook again, and now let's say I go here and I want to say print tomorrow is tomorrow. If I try this, it says, oops, tomorrow is not defined because the kernel is shut down, all our variables are gone. So we need to actually run the code to get all those variables back into our notebook. So one handy way to do that is if you have a notebook and you want to run all of the code, because right now we've been running each cell individually, but if you want to run all of the cells, you can go to the cell menu at the top and say run all. And now it will, my variables I have, because it's run the previous code up top here where I define them. And another thing to be aware of, so this is very different if you're used to working with scripts where you just write a script and all of the code in your script runs from the start of the file to the end of the file. You can't pick and choose bits and pieces to run individually. So this is what's called nonlinear, these notebooks. And sometimes that can lead to unexpected behavior, which you just want to be aware of. So for example, let me change and say today equals Tuesday. And I'm going to run that code. Now, if I go up here and I want to run this cell again, what do you think the output will be? And let me, I'm going to say today is Friday. I'm going to put 2 options in Slack. So I made a poll here. Yes, exactly. So everybody is finding that now it is outputting today is Tuesday, even though previously up here we said today equals Friday. So if you start running cells out of order, you can get some strange behavior. So it is useful when you're creating a Jupyter notebook to periodically just restart the kernel, which clears all your variables, and run everything again. So it's kind of like running a script. So if I go to the kernel menu, I can say restart and run all and confirm. So now everything, it says today is Friday, as we expected, because we previously defined today to be Friday. So it's a good practice to do this periodically, restart, run everything through, and just make sure that you haven't introduced any bugs from, for example, editing something and then going back and running a previous cell with a new variable value. Okay, let me see what else I wanted to cover. So now, if you want to, for example, insert some cells, like let's say I want to insert another cell in between these two, I can go to the menu and click the plus button, and it'll insert a cell below here. And so I can say 1 + 3. And so now I can, as I'm editing my document, if I want to add something and I don't want to just add it to the end, I can actually go back and add it in a different place. There's also keyboard shortcuts for all of these. So in the lessons online, I've linked to a tutorial for a Jupyter notebook that I wrote for a previous workshop, and I've listed a bunch of the keyboard shortcuts there too. So those are really handy if you start working with shortcuts. If you're working with notebooks a lot, then this shortcut's coming in handy. Okay, and the other thing we can do, so you'll notice that when we closed this notebook and we opened it again, it still had the output from all of our the previous time that we ran the code. So it remembers it. When you close the notebook, it keeps the output that from when the last time you ran it. So if you want to actually clear all the output, there's a couple different ways to do it on the menu. So one option, you could say restart the kernel and clear the output. So this is going to restart, which will get rid of all our variables, and then it'll also clear the output. So now you can see there's no output after each of these cells. So we would have to actually need to run them again to see the output. Okay. And I think that, let me make sure I talked about everything. Oh, there's a few other things you can do as well. So if I want to merge some cells, so right now I have these 2 variables defined in separate cells, I can select both of them. So I press Shift and then I select, and I can select, say, all 3 of them. And there's a few things I can do. I can run all 3 cells at once. Or let's say I want to merge them. I can select all of them and go cell. Nope, it's an edit. Merge. Oh, sorry. I usually use there's a slightly different interface called Jupyter Lab, which I normally use. So I'm not, the commands are a little bit different. So actually, so what I want to do, let's say I want to merge these two cells. I'm going to select this and select edit and then merge cell above. And now the two cells become one. So if I run it, it runs both of those commands. And let me just see. Okay, so one other thing we'll do to make sure that you can get back to your notebook. So let's save our work. Let's close and halt the notebook. And also, we're going to go quit to shut down the notebook dashboard here. And if you're on Syzygy, it'll say log out. So I'm going to go quit. And I shouldn't have done that because my slides were running from that. Okay, let me, I'll just restart it again. So now to restart it, you'll go back to that Anaconda Navigator that we had previously. And I'm just going to restart mine here. Okay, and so if I go here to, I had saved this in the documents folder, and now here's my Datajam workshop folder, and here's my workshop.ipynb. Why do I have two of these? Okay. So now I just need to briefly open up what I had from before. Downloads. Sorry, just disregard this for a moment. I accidentally closed my slideshow, so I need to open it up again. But okay, in the meantime, while I get myself oriented here, let me just do a quick poll in Slack. So we are coming up to, we're getting close to our break time, and I'll just check in and see how people are doing. So I'll just check in with the pacing here. With notebooks.
It seems like you're right on track.
Okay, great. Sounds good. So, all right, so we just have a couple final slides here for this section, and then we'll have our break, which means we're running on time, which is miraculous. Maybe it means I forgot something. I'm not sure, but it's, yeah. So, okay, so that's the Jupyter notebook. So we'll be working in the notebook, and then the Jupyter library is part of this larger data science ecosystem in Python. So with you have your core Python, and then you have third-party libraries that are maintained by external development teams. So somebody maintains the Jupyter library, a different team maintains the Pandas library that we'll be working with in the next lesson, and the Seaborn library that we'll be working with in the third lesson is going to be is maintained by a different team. So you put those all together and you have this ecosystem. And that's what when you were doing the installation and we used Anaconda, that's a package manager that helps you to install and manage all these different libraries. So we'll be using a few of the main libraries from that ecosystem. This graphic here gives you an idea. This is not at all complete, but just some of the others that are available. So depending on what kind of work you're doing in Python. And so in the next lesson, we're going to be working with Pandas, which is for tabular data. And we will also do some visualization with Seaborn and another library called Plotly in the final lesson. And I think, okay, so we are ready for break time. We have a few minutes here. I scheduled a break for 6:15. So if anybody, let me just check in. How are we doing? Are there any things still on the Slack channel that we need to address, or does anybody want to chime in with anything? Lisa, please let me know. Where are we at?
It seems like everything is good so far. In fact, I feel like most of the issues that we've had has been with WebEx. So I think hopefully, if anybody's having any WebEx issues, this is a good time for us to help hash that out. Lauren has a question, actually. She asks, I missed how to tell where your notebook is being saved on your computer. So I think this is a very good question. Yeah.
Definitely. And it can be a little bit confusing, especially depending on what system you're working on. If you're on Windows or Mac, it can be a little bit different. So if I go back here to when I very first started my, now this is assuming, yes, you're talking about locally on your computer. Yes. So when I first run the Jupyter notebook and I select it from the Anaconda navigator, it will start out in my home directory. And so this is basically just the sort of the root directory where all of your other directories or folders, those are synonymous. So where they're stored. So you might have on your computer like downloads, documents, music, pictures, and so on. So when you start, and this top bar here tells you where you are, so what your current working directory is. So this is the root folder. So when I created that new notebook for the workshop, I went into a documents folder here, and then you'll notice here up at the top, now it has my root folder, and then it has documents. And then I created a subfolder here and I called it Datajam Workshop. And that's where my my workshop notebook is stored. So if you exit, like if I click up here, which I won't do again, so I don't shut down my slideshow accidentally. So if I click quit, and now the next day I come back and I go to Anaconda Navigator, I click on Jupyter Notebook, it may remember, it might be different on your operating system. It may remember where you last were. So it might actually open you up right here, or it might start in this root directory, in which case you follow the subfolder. So the specific one will depend on where you saved it when you created it initially. Does that make sense? Does that work for you?
It's also worth noting as well, if you're using the syzygy service, you'll need to manually download your notebook as it's saved on a server that's not on your computer as well.
Yes, thank you, Lisa. So there will be an option for that if you're in syzygy. Let me just quickly, where was it? Yes, this is syzygy. So if I create a new notebook here, I can go to File, and then I will go Download. Download as. Sorry, I haven't actually tried this out on syzygy. Maybe there's a way to. It must be download as. But I can't see the option. Okay, I might have to look into that during the break and get back to you because I don't see it off the top of my head here, but there should be a way to download it locally. Okay, so let's, where are we?
Yeah, Margaret made a really nice observation. So if you go to File, there's Download As, and then you can download as IPYNB.
Oh, it is there. Okay, it must just have gotten, oh yes, I missed it. Yep, perfect. Thank you, Margaret. That is brilliant. So yes, if you say download .ipynb, and then you can choose and it'll download to your local machine. Yes. Okay, great. So it's 6:15 and I said, yes, we'll do a 15-minute break. So go and grab a snack or a stretch or a washroom break, and we will reconvene at 6:30 to do pandas. All right, so I guess it's 6:30. So we can switch to the next lesson now, which will be Intro to Pandas. And I think Lisa posted the link already, but if you, all of the material we'll be covering now is you can see online as well. So if you prefer to follow along, and you can, if there's like some longer bits of code, if you want to just copy paste, feel free to do that. To make life easier as you go along. So we will now dive into pandas. Okay, so in this lesson, we're going to talk about how to read and write CSV data, and some really quick and easy ways to summarize your data, which I find very handy anytime I have a new data set that I'm trying to wrap my head around. And then we'll go over some of the basic data manipulation operations. So selecting columns and rows of a data table, creating a new column, and we'll probably skip sorting unless we have like tons of extra time. And then we'll finish off with grouping and aggregation. And the material, you'll notice if you're looking at the slides online, there are some sections I've called bonus, because like I always have like way more stuff I want to talk about than I have time for. So there's bonus there. So if you're speeding through and working ahead, feel free to look at the bonus material, or if you want to if you're working on this material after this weekend, you can go through the sections that we don't cover at your leisure. Okay. And there's also some great tutorials on the Pandas, the official Pandas website, and a Pandas cheat sheet too, which has a whole bunch of syntax, which can be helpful as a reference. And also, I should mention, I put together, so when we get to the point where we're working on exercises, I put together a syntax summary of the, where did I put my slides? There they are. Let me just show you. So there's syntax summary here, which might be helpful as well. So all the things that we're covering, there's just a quick summary that you can refer to. Okay, so Pandas is the Python data analysis library, and it is designed for working with data tables, so where you have your data organized in rows and columns. And in Pandas, these are called data frames. And you can work with data in all kinds of different formats in Pandas, so CSV and other text files, Excel spreadsheets, and many other formats. You can read in different formats, work with your data as a Pandas data frame, and then you can write it into a different format as well and save it as a file. And so with Pandas, you can do pretty much everything you would with a spreadsheet, plus a whole lot more. So Pandas really is the powerhouse for working with data, and it's great for if you have big data files and complicated calculations. If you have messy and missing data, it has really handy functions for handling that. You can merge data from multiple files. If you work with time series data, which I do a lot, it has really, really great tools for time series. You can use it in scripts to do automation. And of course, you can combine it with other Python libraries to make beautiful and customized visualizations. So Pandas is awesome. I love it. We're just kind of scratching the surface today, trying to get you up to speed on the basics, but there's lots more you can do with it than what we covered today. So if you want to learn more, you can check out the other tutorials and resources that I've linked in the notes. Okay, so if you're in your Jupyter notebook that we created, the first thing we want to do is import the Pandas library. So now I have imported it. And we're going to be working with some data which is online, and we'll read it from a URL. So the data set we're working is from the Gapminder Foundation, and it has information about countries around the world from 1950 to 2015. And so we have variables like population, GDP per capita, population density, years in school, and so on. So if we, and it's saved in a CSV file. So if we want to read data that's in a CSV, we use the read CSV function from Pandas. And this, so the link, if you have the notes open, you can grab the link from there. It's a bit of a long string. So what you do is you have the pandas.read CSV function, and then you have a URL, or also you could have the path of a locally stored file, and you include it as a string. So you can copy, you'll want to copy paste that from the notes. And then we're assigning it to a variable called world. So now, if I display the world variable, it looks like this. So we can see that it looks like a table, and it has the columns that we expected. There's a bunch of columns. So if I want to see the ones to the right, I have to go to the bottom here and then use the scroll bar, and that will scroll. So if I go up, I can see the columns further to the right. So I can scroll up and down and right to left. If everybody, I'm hoping everybody was able to read from that URL. Actually, here, why don't I just copy paste? So it'll be in the Slack channel right here, if you need the URL, because this is what will be, this data frame is what we'll be using for the rest of this lesson. Okay, so you'll also notice it has at the bottom that there's 2,492 rows and 13 columns. And it doesn't show all of them. We can see there's this ... here. So it's truncated the middle rows, and it just shows the first 5 and the last 5. But the data is all there in the world variable. And the way this data is organized is that each row of a table is an observation, and it contains the data for one country in 1 year and the values of all these various different variables: population, region, subregion, and so on. And also, if you scroll to the far right, you may notice a few of these weird values that look like this, NaN. And that stands for not a number, which means that this cell in the table is empty, the data is missing. And that's how Pandas represents missing data. And I've hinted at this already, but if we want to see what type of object our world variable is, we can use type world, and it'll tell us that it's a Pandas data frame. And so this is a 2-dimensional array, and it's very similar to having rows and columns like a table in a spreadsheet. You'll also notice when we display the variable world, there's these integer numbers on the left. So let me scroll up here. Oops. So these numbers on the left, 0, 1, 2, 3, 4, in bold, they aren't actually contained in the CSV file. They're added by Pandas automatically, and this is called the index of the data frame. And you can do a lot more with indexes. We won't get into that at all today. So just be aware when you see these numbers, they just correspond to the row numbers, and they are the index of the data frame. So now let's use a method called head. And so this belongs to, it's a method that's specific to Pandas data frame, and it allows us to see the first few rows. And by default, it will give you the first 5 rows. If you want to see the documentation for it, for example, I mentioned in the previous lesson, we can do world.head and then with a question mark at the end of the method name, and it'll show me the documentation. So we have that it gives the first n rows. And so if we want to show a different number of rows, we can use that argument. Another way to see the documentation, which is pretty cool as well, is you can, as you start typing it inside the parentheses, if you press Shift-Tab, a little mini version of the documentation pops up and you can expand it and see it there, which is sometimes a little bit faster. So if we want to show just the first 2 rows, we can give it the argument of head 2, and then I won't create a poll for this, but just before you run the command, if you have any guesses about what you think the tail method does, so world.tail3, what do you think the output will be? And then you can run it to see that it gives you the last 3 rows. So when you're first working with a new data set, it's useful to summarize it in a few different ways to get a feel for it. And Pandas has really handy ways of doing that. So you can see how many rows and columns there are, what are all the column names and the type of data in each column, how many values are missing. And when you have numerical data, we'll show there's a very easy way to show for each numerical column what's the average and range of values. With text data, we can easily see what are the unique values in that column, how often does each one occur. We won't cover all of these, but we'll cover most of them, and then you can see the bonus sections for some of the others. So first of all, whenever I'm working with a new data set, the first thing I want to know is how big is it? So if we use the shape attribute, and you'll notice there's no parentheses here because it's actually a data attribute. It's not a method, so it's not a function. So this is just a variable that's contained within our world data frame. It gives us the number of rows as the first element in the tuple, and then the number of columns. And a very handy method is the info method. So if we run the command world.info, it gives us this output, which tells us the number of rows. We can see the number of columns, the name of each column, the type of data. So each column in a data frame has to contain data of the same type, and the memory usage. So we can see that we have a combination of different types of data in our data set. We have integers, which are called int64 in Panda, float64, which are floats, and then object. And an object is basically anything else. Most of the time it will be text, which is what we're working with in this data. So country names, region names, that sort of thing. But an object also could be anything else. It could be a list or a dictionary. Any of your Python objects could go in there. And then this non-null count here tells you how many values there are in that column. So if it's a null value, it means it's missing. So most columns have complete data, but we can see the last couple of columns here only have 1,780 non-null values, which means that there's some missing ones because then this number is less than the total number of rows. If we want to just see the column names on their own, we can use another data attribute, which is the columns attribute, and it shows just a list of the column names. The output here is a little bit wonky just from my slideshow settings, but when you run it in your notebook, it should this should all be formatted more nicely without the extra line break. Okay, so another really handy method to summarize the data frame is the describe method. And this gives us some really simple summary statistics. By default, it will summarize the numeric columns. You can also use the keyword arguments to do a different type of summary for the text columns. But if we just do the numeric columns here, it'll tell us the count, the mean, standard deviation, minimum, maximum, and various percentiles. So this is really handy. For example, looking at this, we can see what the range of years is in our data, looking at the minimum to the maximum, the range of life expectancies, and so on, and the mean value for each. So it gives you a sense of what your data looks like. We could also look at each of these statistics individually. So instead of world.describe, we could do world.mean, world.max, and so on to just look at those statistics individually. Okay, so we have come to our first exercise. So we'll take a few minutes to work on this, and maybe about 5 minutes. And if you have any questions, please post them in the Slack channel. Our helpers are ready and waiting to help you. And so we will let's take 5 minutes, and we will reconvene to go over the solution of this exercise.
Jennifer, someone is asking, where do we post the exercise questions, if at all?
Oops. Where do we post?
I think they mean their answers, and I think the answer is just don't post it anywhere.
Oh yes, so you can just write down your answers in a markdown cell, or just think about it. Yeah, you don't need to submit it anywhere. It's just for you to work on your own, and then we'll go through it together.
Sure, thank you.
Okay, so hopefully you've had a chance to give it a try, and let's now go through the questions. So let me display world.info again. And sorry, having a little bit of issues. There we go. What data type is the pop density column? So if we look at the table here, we can see that it is float 64. So it's a float. And then based on the output of world.describe, let me just change this here. World.describe. What are the minimum and maximum years? So we can just read those off the table. So we look at the year column and we have minimum is 1950 and maximum is 2015. Okay, so we'll move on. Hopefully that made sense. If anybody had any issues, please just post in Slack. So now let's talk about how to save to a CSV file. So we have our data frame right now in our Jupyter notebook, and we read it from the URL online. So let's say we want to save it locally on our computer. We use the method called toCSV. And so the syntax is world.toCSV. We give it the name of the file, and this will just save it in our current directory. So you could also, if you had a directory called, for example, data, you would do data / if you had a subdirectory, we'll just save it in the working directory right now. And I'm using this argument here, index equals false, because that index that we talked about earlier that Pandas automatically added, we don't want it to save that as an additional column. So we use index equals false. So if we run this command, then we should find that in our folder, there will be a, I've got a bunch of other stuff in here, but I just saved it. Gapminder world data.csv. This is the new file that we just saved. And so we can view it from the Jupyter Notebook dashboard here. It'll open up in a text editor. And so you can see that all the data is there. Or of course, if you have Excel or Google Sheets, you want to view it there. If you use the newer version of Jupyter, which is Jupyter Lab, it actually has a CSV viewer built in, which is really handy. And I use that all the time. But in this case, because Syzygy was set up with the classic Jupyter Notebook, I just had, we'll do everything in classic Jupyter Notebook for the purposes of this workshop. But Jupyter Lab is very cool with the CSV viewer and a bunch of other features as well. So with data that we've saved locally, now if we want to load it again in it, say in a new notebook, we could load it from the local path instead of the URL. So what that would look like would be here. I've just created a new variable called world2. And now this is the same data, but it's reading it from this local folder. Okay, I'm seeing a question. Does toCSV save it into your personal files? Yes, you should be able to see it. So it will depend where you are. So it should be in this, like if you would also be able to see it if you're in your folder navigator, like on Windows, it would be the Windows Explorer, or if you're on Mac, I'm not sure what it's called on Mac, sorry. But yeah, it should be in the same place where your notebook is. So hopefully that makes sense. If a bunch of people are having issues with this, please post in Slack so I know, and I can try to demonstrate online here. Otherwise, I'll leave it to the helpers. Okay, so with our data frame, if we want to select a specific column, we can index it. It's very similar to a Python dictionary where you have square brackets and then you have the name of the column in as a string. So if we look at world, the year column, this is now showing us just the data in the year column. And again, that index is here on the left. And a really cool thing in Jupyter Notebooks is you can actually use autocomplete for column names too. So if I do something like world and if I start typing CO and then I press tab, it should come up with, seems to be a little bit slow on my computer. It has a few other options here which we can ignore, but it'll show country. And so when you're selecting a single column, you can actually use the autocomplete, which is pretty cool, especially if the column names are longer. So when we look at, let's go back to what we had before, year column. Okay, so if we want to see what type of object this is, because the output display looks a little different from the data frame, it is a different data structure. It's called a series. And so this is the other main data structure in the Pandas library. So the data frame is a two-dimensional array, like a table, and a series is a one-dimensional array. So this is like a single column or row in a spreadsheet, and each column of your data frame is represented as a series. So we can also use the methods that we used on the data frame. We can use those on the series as well. So the head will show just the first 5 rows. You could use describe, tail, info, and so on. There is another notation that can be used with a dot, like an attribute. But in this case, we're going to just, I'm going to stick with using the string notation in square brackets because when you select multiple columns, which we'll do next, you have to use that notation. So it's just a little easier to be consistent. So if I want to select multiple columns, I use the square brackets, and then inside them, I give a list of column names. So now we've selected the country and the year columns. And notice we have the double brackets here because we need the outer brackets are for selecting, and then the inner brackets are for defining the list. And when we select more than one column, this output that we got is a data frame rather than a series. And you don't need to worry too much about the difference between data frames and series, but you'll just notice that they display a little bit differently in the output. So far we've just displayed these subsets in our notebook, but if you're going to be reusing a particular subset frequently, then you can assign it to a new variable. And that way you don't have to type like all of this out again. You can say, let's call it populations. And so now we have a new variable called populations, and it just contains these 3 columns. We can use methods like any other data frame, describe, and so on. And that will always refer to this subset that we defined here when we created the variable. And if you are extracting a larger number of columns, and this got truncated a little bit here. So for example, let's say we want to select this list of columns. It would be a lot to type in within the subset here. So we can just create an intermediate variable, call it subset columns, where we define our list. And then we use that inside the brackets instead of typing this whole list inside there and getting a very long line. Just makes it a little more readable. Okay, we'll skip this. Let's move on to selecting rows. So there's a whole bunch of different ways to select rows. We aren't going to go through all of them here. We're just going to focus on one, which is where you want to select rows that fit a certain criterion. So for example, if we want to select the rows where the life expectancy is greater than 82 years in our data, we can use a method called filtering, which is basically the same as applying a filter in Excel. So the way we do this is we use the comparison operator on the life expectancy column. And so this is going to take each element in the life expectancy column and check if it's greater than or less than 82. And now it returns a new series of Boolean values, which can be true or false. So each element in this series, it will be true if that row, so each row of the series corresponds to the row of our data frame. So if the life expectancy value in that row is greater than 82, it will be true, and otherwise it will be false. So we can use that series that we just created of Boolean values to see how many rows match our condition about the life expectancy greater than 82. And so we can create a variable, we'll call it above 82. And then we just take the sum, and it treats the trues as 1 and the falses as 0. So we can see that there's 13 rows where the life expectancy is above 82. So now when we want to extract those rows, we use this Boolean series as a filter. And we're going to use square brackets to do this. So previously we used the square brackets to extract a column or several columns. In this case, inside the square brackets, we are putting this Boolean series of true and false values. So now, if we scroll through, this is actually the entire data frame, and you can see the rows are all rows which have life expectancy greater than 82. And so from extracting this subset, we can see like which countries match those conditions and which years. Most of them are all in 2015. There's a couple of them that were also in 2010. So we can use any of the regular comparison operators from Python to filter our data. So for example, let's take another subset, and we're going to take the rows that correspond to the East Asian countries. So here we're using the double equals operator to check if the subregion is equal to Eastern Asia. And we're creating a data frame. And we can see here there's a lot more rows, and it's actually 70 rows that fit that criteria. So now this East Asia data frame just contains those 70 rows. And if we want to take a further subset, so we have the East Asia subset, and then if we want to, here we go, we can filter that subset even further. And let's say we just want to take the year 2015. So now we take our East Asia data frame and we filter with the condition that the year is equal to 2015. And now we have a much shorter data frame, which has these 5 countries in the year 2015. Now, if we want to select rows and columns at the same time, we use a syntax .loc, and you first put the rows that you want to select and then the columns. And in my slideshow, this is getting truncated, so I'm just going to split it into separate lines. You can always do that anytime you have a long expression in here. So the first part here is this Boolean series where I am comparing the country to see if it's equal to Canada. And then we have a comma here, so this separates the rows and the columns. And then we have the list of columns that we want to extract. So now, if we look at this data frame that we created, it has just the columns country, year, population, and we've just shown the first 5 rows, but if you check the whole thing, you'll see that it's only the country Canada. And yeah, we already talked about splitting onto multiple rows. So this is just another example. So if we look at, for example, here, extracting recent data, comparing to a year greater than or equal to 2010, and then a bunch of columns here, we have a different subset as well. Okay, so we have come to our next exercise here. So we are going to extract some subsets, and we'll take about 5 minutes for you to work on that in your notebook, and then we will reconvene and go over the solutions. And please, if you have any questions, post them in Slack. Also, let me know. Maybe I'll put up a poll again to just check how the pace is going. And you can let me know if I should slow down or speed up or anything like that. So let's work on the exercise, and we'll reconvene in 5 minutes.
Then I'm just gonna warn you now. You're gonna get a lot of things that I've sent from Slack.
Thanks,
Sorry,
Lisa.
I'm doing some announcements. Yeah.
Okay. I'm trying. I put my phone on. It seems to have taken itself off of Do Not Disturb. Let me change that so it doesn't keep pinging. Thanks for the heads up. Hmm. Whoops. Okay, that did not work. I tried using this other app for the polling and I couldn't get it to work properly.
Oh, for the vote?
Yeah.
Oh
Jennifer, feel
no.
free to let it paste kind of what you intended to use as the poll in the helpers channel, and I can help figure out what might have went wrong.
Okay, I basically just wanted
Maybe
to use the same poll as before, just how's the pace about right, or prefer faster, prefer slower. Let me.
I can
Okay,
help
I'll paste.
figure that out.
Okay, thanks. Helpers.
Looks like there's 2 questions for you in the Slack channel, Jennifer. So if you want to address them after the break, or kind of direct one of the helpers to help them, feel free to do that.
Okay, thanks. Let me check it out here. Format the population column so that commas. Oh, I see. Okay. So Margaret had a question. Is it possible to format the population column so commas are displayed like the thousand separators? I think that's what that means. I think there is a way to do that. There's a method called, I believe it's .format, but I don't remember the syntax off the top of my head. So I'd have to get back to you on that, or one of the helpers might know. So feel free to chime in. But there is a way to do that when you're displaying it, but it doesn't show the commas by the thousand separators by default. Okay. Let me just. Filtering, multiplication. Yes. Okay. So Joanne was asking about filtering and multiplication. So yes, you can use .loc to filter rows and also select columns at the same time. So from the replies, it looks like you found your answer, but if not, just let us know in Slack and we can try to clarify further. Okay, so why don't we go over the exercises and whoops, I need to just do some edits here. I can. If everyone's ready, if you need some more, if you need some more time, I'm just posting in Slack. I posted, need a few more minutes, please. So you can add an emoji, like a thumbs up on that if you want some more time. If I don't see any thumbs up, then okay, everybody, it looks like some people are wanting a couple more minutes to work on the exercises. Yes, okay. Let's take a few more minutes then, and if there's anything I can clarify or explain more, then please let me know. Okay, so I think maybe what we'll do now, I'm seeing a question in Slack. Let's go over the solutions to this exercise, and hopefully that'll answer if people have any questions still that wasn't making sense when they worked on it. And we'll go over the solutions, and if there's still confusion, we can spend some more time on this. And if everybody's feeling good, then we'll move on to the next section. So let's now create a data frame here called Americas. And we're going to use the syntax world.loc with square brackets. And maybe if anybody wants to volunteer, if they were able to get this working, what expression did you put in here inside for the first part to filter the rows? If you could post that, if anyone wants to post that in Slack. And if not, I will just show the answer, but I'll give you a second if anybody wants to share, if they got it working and want to share their answer. Yes, exactly. So we have, I'm just going to copy Margaret's answer here. So to filter, we want to compare the region column. We use the double equal sign to check if it's equal to, and then it's Americas is how that region how that region is labeled. Okay, so next we need a comma, and that's going to, now we've specified the rows, we use a comma, and I'm going to do a new line here so it doesn't get truncated. And we want to put something here for the column. So if somebody wants to volunteer, if they were able to select the columns, what expression did you put in this part? I can copy paste. Yes, it looks like Shubham, sorry if I'm mispronouncing, has got the answer here without .loc. That's right, yes. So, oh yes, so that's a great point. So in Slack, Shubham is saying that that they did this they first selected the columns, and then in a second step, they selected the rows, which you can absolutely do as opposed to using .loc. And sometimes that's a little bit easier. So let me put this here, and our rows are truncated. So we've got our rows filtering, and then we've got our list of columns, and we've defined Americas, and I said let's display the first 20 and last 20 rows. So we'll do Americas.head 20. And sorry, I need to switch here because I got truncated. So now we have a data frame which has just the Americas, and it has these columns: country, year, subregion, income group, and population density. So that's the first 20 rows, and then if we want to do the last 20 rows, we will do Americas.tail 20, and this is going to show us the last 20 rows. So we've extracted our subset, and then the last prompt that I gave was to use the unique method on the country column to display the list of unique countries. So let me I'm going to insert a cell here. So now the way we'll do this is Americas. So this is the new data frame that we created of, country. And then we use the method called unique. And this shows the list of the countries and confirms that we've extracted the region group that we wanted, which was the Americas. Okay, so I will, if anybody is wanting me to pause and go over this a bit more, please post in Slack and I'll ask the helpers to give me a heads up if we want to clarify anything further, if it's not making sense. Otherwise, I will carry on and we'll go through the next couple of sections. So often what we'll want to do with a data frame is create new columns where we've done some calculations involving the columns that are already there. So for example, we have a column called GDP per capita. And if we want to find the total GDP for each country, we need to multiply by the population. So we can do that using the multiplication operator from Python. And this will multiply each row, the values together, and then we can assign it to a new column in our data frame. And so this is very similar to when you're working with a dictionary and you want to add a new element to the dictionary. You just use the square brackets, you give it a name, and you assign it a value. So if we do this, then we have our data frame and the new column is added at the end. So I need to scroll all the way to the right here. And our last column used to be the years in school women, but now it is GDP total. So this is the value that we calculated. So as another example, and we're going to use this one later on in the visualization because the numbers. So as someone was mentioning in the Slack channel, the population is a really big number. So it can be easier if we want to just look at it, divide it by 1 million. So one e to 6, that's the scientific notation. So we can create a new column. We'll call it pop_millions, so population in millions. And we take the population column and we'll divide it by 1 million. And so now I'm going to just display here. I've done this just so we can display a smaller data frame. If we display these columns, we can see this is our original population. And then this is the population in millions. Okay, we're going to skip sorting because we don't have time. If this is making sense, I'll move on to the next. Please give me a heads up if you want me to clarify. Otherwise, we'll go to the last section for this lesson. Okay, so one of the data manipulation operations that we often want to use with data like this Gapminder data set that we're working with is to divide the data into groups. So for example, the regions like Asia, Europe, Africa, and take all of the rows within that group and perform some statistic on that group, calculating the mean or the minimum, maximum, that sort of thing. So that's what we're going to cover in this next section. And to make life easier, we're going to extract a subset of our data. We're just going to work with 1 year worth of data. So we're going to take the rows of our world data frame where the year is equal to 2015. So I've created a new variable here, and this is what we're going to use for the next series of slides is world_2015, which contains only rows with the year 2015. Okay, so let's say we want to find, we have these different regions, Asia, Europe, Africa, Americas, and so on. And if we want to find the total population of each region in the year 2015, what we could do, we've seen how to extract, we could extract, using the techniques we just learned, we could extract the rows where the region is equal to Asia, take the sum of the population column, then take the Europe subset, add it up, Africa, and so on, but that would be really tedious. So what we'll use instead is grouping and aggregation using Pandas built-in methods to do that. So if you've ever used pivot tables in Excel or group by queries in SQL, it's the same operation. So aggregation is called a split, apply, combine technique. So where you have, in this simple example here in the graphic, we have values A, B, C, A, B, C. We're going to split these rows into groups. So we have, these are the rows where you have A, where you have B, where you have C. Then you apply some statistic, for example, take the sum, and then you combine them back together. So you get value. So it's a little abstract in the diagram. So let's see how it works in our real world example here. So there's a method in Pandas called group by, which is exactly what it sounds like. You are going to group by, and then you specify the column that you want to group on. In our case, it's the region. So we want to split our data up into groups that are based on what region it is. And then what we're going to do is take the population column. So we use the square brackets again, and then we take the sum, and this is the aggregation. So it could be the sum, it could be the mean, the minimum, the maximum, and so forth. So let's see what the output looks like. We have each region, and we have the total population. So it has summed up all the rows where the country or where the region was equal to Africa, and it took the sum of the population for Americas, Asia, Europe, and Oceania. Now, by default, what we got here was a series. So the region here is the index, and then we have these values. If that doesn't make sense, don't worry about it. I'm just going to show you a different syntax here. If I specify as index equals false, then we get the same information, but it returns a data frame instead, where you have a region column and a population column. When you're visualizing data, many of the functions will expect the region to be as a column and not the index. So this syntax is just a little bit easier. So I just wanted to introduce that to you so you were aware, but either way, it doesn't really matter. But you just to know that you have a couple of options there. So as another example, let's suppose we want to find out what is the largest population in each region. So each region has several countries, and we want to know what is the highest country population, population density in this case, in this example, within each region. So we're going to do the group by. We are grouping on region, and then we're going to take the population density column and take the maximum. And we can see here the highest population density. So each of these corresponds to one of the countries in that region. We can see in Asia, we have a very high population density in one of the countries. Excuse me. So you may have some guesses as to which country that might be. And you could also think about, as a bonus exercise, how you would figure out which country that is that has this high population density using the methods we've learned so far. There's much fancier ways to do the aggregation, which we won't get into. So let's see. Yeah, and then we're at the last exercise. Okay, so we're actually doing quite well for time. So we have an exercise here, and I can also, if there's any clarification that's needed, let me see, what was our schedule? We were going to have break at 7:45. So yeah, we have some time. We can spend, like, say 10 minutes to work on the exercise. Then we'll reconvene and go over the solution. And then we can have a proper break before we do the final lesson. So please post in Slack if you have any questions, if you want me to go over anything or clarify anything. So let's take just, well, not quite 10 minutes. We'll take until 7:40 and to work on it, and then we'll do the solutions and then a break. Okay, so it's 7:40 now. I'm just posting in Slack. If you would like a few more minutes before we go over the solution, then please react with an emoji to my post where I said more time, please. And what we'll do is you can have a few more minutes, and we'll just have a slightly shorter break in between the next lesson. Okay, I'm getting some yeses. Okay, so what we'll do, let's give it another few minutes so you can work through it before we go over the solution. And we'll take, instead of having if it's all right with everyone, we'll just, instead of a 15-minute break, we'll do a 10-minute break before the next lesson. Okay, so let's go over the solution to the exercise. If anybody was able to get it working and would like to share your solution, please post it in Slack. I'll give you a minute or so to copy paste. Oh, looks like we've got an answer. Awesome. Yes. All right, so here is a solution. So we've created a data frame called group, and we're taking the world data frame. We're using .group by year. So we're grouping on the year column, and then population. We're taking the sum of the population column. So if I run this, and then I'm going to display group, and sorry, the scrolling, I just have to go back, and then here we go. Now it shows up. So now we have each year, and this is the total world population from all the countries, going from 1950 to 2015. And we have, yes, someone else posted another solution as well using the as index equals false. So that also works. We have two options there. Yes, so that we could now, we'll see in the next lesson, we could, if we wanted to see how population has grown over time, we could plot this aggregated data using the data visualization libraries in Python. So, okay, we're actually doing pretty well for time. Is there anything from this lesson that you want me to spend another couple minutes to clarify or go over again? please let me know in Slack. But otherwise, if I don't see any requests there, we'll just have a 15-minute break, and you can also get one-on-one help as well during the break. We're gonna reconvene at 8 o'clock to start the data visualization lesson. So I'm seeing a question in Slack. So what I'll do now is anybody who wants to take a break, feel free to take your break now. I'm going to stay here and answer some other questions that are coming in if anyone's wanting a little more clarification. But we'll all reconvene at 8 p.m. to start doing data visualization. Which country has the highest population? Yes, that's a good question. So in the earlier lesson, we talked about, we showed that there was one country that had a very high population density, like above 7,000, I believe. Let me go back where we were. Yes. So in Asia, we had a country with population density. So in the previous section, we talked about selecting rows based on a criteria. So we selected rows based on the life expectancy being greater than 82. So can you think if I wanted to look at which country has a population density of equal to 7,910, or you might just make it say greater than 7,900. How would you select those rows? You could look at them and see which countries there are. If anybody has an idea there, feel free to share. I'll show it here in a minute, but I'll give you a minute or two to think about that and try that if it makes sense. Okay, I'll show here, I'm just going to use this slide. So if we want to see which country has that high population density, let's take a subset where we're going to take world of pop density is greater than 7,900. And let's display that. And it turns out there's actually only one row that matches that condition. And so it is Singapore, not surprisingly. And so whenever you see some of these statistics in the aggregated form and you want to dive into it more, often extracting subsets using the filtering techniques that we learned can be an easy way to do that. And you can just visually look at which rows match that criteria, and you can answer questions like that. Does that make sense? If that's not clear, let me know, and I can try to clarify. Okay, I'm going to take a quick break myself, and so I'll be turning off my camera and mic for a few minutes, and then I will see you guys at 8 o'clock. All right, so let's get started on our final lesson, data visualization. So hopefully everything we covered with Pandas is making some sense, and we're going to look at a few options for how to visualize data. And so we'll talk a little bit about the visualization landscape in Python, because there are many different libraries, and today we're just focusing on a few. So we'll show how to do some very simple plots using pandas. And then we're going to focus most of our time on the Seaborn library, which is for statistical visualizations. We'll talk about different types of plots, relational, categorical, distribution plots. We'll learn about semantic mappings and facets. I just realized I've never actually said that word before, so I'm not sure if I'm pronouncing it correctly. I'm going to call them facets. How to do statistical transformations in a visualization, and then at the very end, we'll just do a tiny introduction to the Plotly library for interactive visualizations. There's also some really great tutorials for each of these libraries. So if you want to learn more, you can check out those links as well. If your notebook from the previous lesson is starting to get long, you feel free to start a new notebook. Or you can just keep going in the same notebook you have. I'm in a new one here for this next lesson. So this is the code. If you do start a new notebook, you'll want to just copy paste these lines of code to import the libraries and then read the data. We're going to be using this column that we calculated for the population in millions. And also this subset for the year 2015. So you'll want to make sure to run those lines if you're in a new notebook. So these are just a few of the visualization libraries. And one of the biggest ones and the oldest ones in Python is called matplotlib. And when we show how to make plots with pandas and also Seaborn, those are both actually using matplotlib behind the scenes, and they're providing it like a high-level interface to create matplotlib plots. And then there are various other libraries that are not based on matplotlib. They have their own separate tools for creating plots. And so a couple of those are Bokeh and Plotly, which are both good for interactive plotting. And we will give a brief introduction to Plotly at the very end here. There are many, many, many more. So this is from a talk by Jake Vanderplas, who's a really awesome data scientist, just giving this isn't even complete, but like a picture of the different visualization libraries in Python and the relationships between them. And so we have these different, for example, matplotlib here in this central node. And then a bunch of different libraries that are built on top of it, including Pandas and Seaborn that both use it behind the scenes. And then you have a bunch of JavaScript-based libraries, and Plotly is one of those. And then various other ones as well based on D3.js and other frameworks. So it can get pretty confusing when you're doing visualization in Python in terms of which library should I use. It's great because there's so many options and you can create such a huge variety of plots, but it also can be overwhelming as to what to use. So we're focusing on just these three in this lesson, and mainly Seaborn because it's really a powerhouse for data analysis. So Seaborn, as I mentioned, uses matplotlib behind the scenes, which is a low-level, very detail-oriented library. Seaborn provides high-level functions on top of it. You can create really beautiful figures and it's very easy to customize them with different themes, and it's it focuses on statistical data visualization. So the syntax really focuses on expressing what you're exploring in the underlying data rather than which graphical elements you want to add to the plot. And these are just an example of some inspiration of the different types of plots you can make with Seaborn. And then the Plotly library is is for interactive plots, so ones that you could put on in a website or create an interactive dashboard, and you can do a huge variety of different plots with Plotly as well. And I've recently started using it just in the past year or so, and I really love it as well. It's very, very nice to be able to create interactive plots. And the nice thing with what we're learning in Seaborn, which we'll be focusing on, a lot of those concepts, the same concepts are used in Plotly as well, or Plotly Express, which is a particular version of Plotly that will be, particular library within Plotly that we'll be focusing on. But before we get into that, let's just talk about how to create some really, really simple plots with pandas. There is a method called plot that it belongs to the data frame data structure, and it will create a matplotlib based plot, and it will give you some useful defaults and labels. So let's start by creating a bar chart of the total population in each world region. So first I'm creating this data frame, and my line is truncated a bit, so let me just split this into a couple lines here so you can see. So we've created a data frame called region pop, which has for the year 2015 the total population in millions of each region of the world, and we want to plot this as a simple bar chart. So we take our region pop data frame, we use the .plot method, and then the arguments here, we specify we want the region on the x-axis, the population in millions on the y-axis, and the kind is bar chart. So now we've created a simple bar chart with the various regions and the population in millions. If you're wondering what this gobbledygook is at the top, it's because this figure, the plot method creates a set of matplotlib axes, which is what the figure is drawn on. And so the Jupyter notebook is also displaying that axes option. So if you want object, so if you don't want to see this, you can just add a semicolon at the end of the command, and it will suppress that output. So we created a bar chart, but there are many different options that you can specify with the kind keyword argument. So you can make scatter plots, line plots, histograms, and a few others as well. So let's now see how to make a scatter plot. We're going to plot the life expectancy versus GDP per capita. So we use the plot method again. We specify GDP per capita on the x-axis, life expectancy on the y, and this time we're seeing to create a scatter plot. So now we have created a nice little scatter plot, and each dot on this plot is representing a single country in the year 2015. Now, you can actually do quite a bit using this plot method with the Pandas data frame. You can, there's various keyword arguments where you can change the figure size and some of the axes properties and colors and things like that. And you can also take the matplotlib axes object that this creates and use its functions and methods to do a whole bunch of other customizations, change the labels, change the look, the style, the sizes of the labels and things like that. We aren't going to get into any of that today, but you can check out the documentation for Pandas and Matplotlib if you want to learn how to do that. So Pandas plots are really convenient if you just want to create a simple plot really quickly. If you want to create some more sophisticated plots, or you want to create, be able to do customizations, a lot of different customizations without having to write a ton of extra code, then Seaborn library is a much better option, and it's very powerful. It's specifically designed for statistical visualizations, and you can create a really wide variety of different plots with very little code. So most of the plots in the Seaborn library are in three main categories: relational, distributions, and categorical. And we'll show what each one of those is. So first, let's talk about relational plots. So relational plots visualize the relationships between two numeric variables. There are two types in Seaborn. You have scatter plots and line plots. And these are a couple of examples. Distribution plots visualize how a variable, one or more variables, are distributed. And there's a whole bunch of different types of them in Seaborn. I haven't shown them all here, but a couple of examples are the histogram and the KDE plot. And then categorical plots visualize relationships between two variables where one of them, the variables on the X or Y axis, is categorical, which means it's divided into discrete groups. So it could be something like a country name or a region name, as opposed to a numeric value like the population or the life expectancy. And there's quite a few different types of categorical plots in Seaborn. I haven't shown them all here, but there is a few examples below, such as the bar plot that we showed previously with the populations for each region of the world. That's an example of a categorical plot. Sorry, I'm just seeing someone's having issues. Okay, if we need to, please let me know if we need me to stop, if people are having issues, if their plots aren't working. Okay, so we're going to focus mainly on relational plots in this lesson. So first thing we need to do is import the Seaborn library, and it's very commonly given the shorthand nickname SNS, just to make typing faster. So we'll use that, and that's what you'll see in all the documentation and the tutorials online as well. So if we want to change to Seaborn default aesthetics, we run a command called set, and this will actually affect any matplotlib based plots that you create after running this command, including ones that are generated by Pandas. So we can use a function called relplot in Seaborn to recreate our earlier scatter plot. So relplot creates either a scatter or a line plot, and the default is a scatter plot. Let's run this command. Here we go. Okay, so we're calling the relplot function, and here we're specifying data equals world 2015. So that's saying which data frame to use. And then similar to the previous plot method that we looked at, we specify the X and the Y, which columns to use for X and the Y axes. And so now we have a nice little scatter plot, and you can see that the aesthetics are different because it's been changed to Seaborn defaults. And Seaborn has a bunch of different themes. You can easily just switch to a different theme if you want to have a different color palette and a different look. We won't get into all of that tonight, but that's you can find that in the documentation. One of the really great functions, aspects of Seaborn is what's called semantic mapping. So if we go back to this scatter plot, we've visualized two variables here. We have GDP per capita and life expectancy, but our data has many more variables than that. And it's nice to be able to visualize more of those on our graph as opposed to just the two. with Seaborn, you can do this with semantic mapping, which is where you map a variable in the data to other visual properties on your graph, such as the color or size. So for example, if we take our previous plot, our scatter plot, we can add this hue equals region keyword argument here. And now our plots are automatically colored according to the region, and it creates a legend automatically. So this is really nice because we have all we had to do was add one more keyword argument, and it did all this extra work for us. So that's one. So now we've added, we had two variables. Now we've added a third variable to our plot. It's possible, depending on how you installed, which installation instructions you followed, adding this hue equals region keyword argument might have caused an error. I found this when I was testing things out the other day. So there's a couple of, it's because Matplotlib, their latest version of Matplotlib, has some conflict with this Seaborn function that's causing this to give an error. And so there's a couple of different workarounds. I don't know. So maybe, I'm just going to put in Slack here so we can see if, I'm not sure if people are getting an error right now, but if you are, there's a couple of different ways to fix it. So I'm just going to say, I'll ask you to add to give an emoji here. Okay, so I just posted in Slack here. So if you got an error when you added that hue equals region keyword argument, can you give a thumbs up or an emoji there, a reaction? Yes. Okay. So yes, this was something I just discovered at the last minute, and I realized that the installation instructions that I had, where I had you update everything before when you're installing it, could cause this issue. So there is a workaround. What you can do is, if you try replace, a very simple workaround that we can do for now is to replace, instead of just having hue equals region with just the column name, if you put this instead. So this will extract the actual values from that column. You don't normally need to do this. It's just because of this weird issue with the new version of Matplotlib and causing a conflict. So if you try this, it should hopefully fix it for you. And then you can use that just for the sake of this workshop. And then in the notes here, I've shown how to actually do a proper fix where you won't encounter this. You can fix the underlying issue by changing the Matplotlib version. So hopefully that fix worked. If not, please post in Slack, let the helpers know. But if everybody is doing okay, then I'll move on to the next. Oh, that's right. So actually, we're at the exercise. So if things are working for you, you can work on the exercise. And if you got an error or you're having issues and things aren't working, then we can spend this next 5 minutes trying to help you troubleshoot. So let's take 5 minutes now, and we will reconvene to go over the solution. So if your plots aren't working and you need help, please do post in Slack and let us know. We'll help you troubleshoot. Okay, I've posted in the Slack channel. If you need a couple more minutes, please react with an emoji to my "more time, please" posting. Otherwise, we will go over the solutions for the exercise. Okay, so looks like I think people are ready to move on. So let's work on part A. If anybody was able to create the plot and would like to share their solution, please post it in Slack. I'll give you a minute or so to copy paste. Okay, so we can work through this here. So I've just copy pasted from the previous example. And now if we want to color the points by income group instead of region, then we just change the hue keyword argument here to income group. And so now we can see it has income group, low, upper middle, lower middle, and high. And then let me add another cell. So now we can also see what happens when we use the aspect keyword argument. And I'm going to add here aspect equals 1.5. And so now it changes the aspect ratio and gives us a wider plot. So if there aren't any further questions about the exercise, I will move on to the next section. So if we go back to the previous plot where we had the scatter plot and the points were colored by region, we can see that the relationship here, sorry, let me go back. Well, actually, you can see it in this plot as well. Okay, so this plot, we can see the relationship between life expectancy and GDP per capita is approximately, looks like it might be about log linear. So we could visualize it better if we change the x-axis to a logarithmic scale. So if we want to do that, what we can do is we assign the output of rel plot to a variable, we're calling it g, and then we can use g.set, and we can set the x scale to log, and then while we're at it, we'll add a title as well. And we'll give that a minute to run. And now, oops, sorry, I'm having some issues with scrolling, that's why I have to keep going back, and then there we go. So now we can see that the points are arranged in, they look like a linear relationship when we change the x-axis to a logarithmic scale. So now we have 1,000, 10,000, 100,000 on the x-axis here. And we can do various other customizations as well using this g.set method. And we also have our title here. We aren't going to go too much into these customizations, but just give you a brief, this is just a brief intro. We can also customize our scatter plot, adding another semantic mapping where the size of each marker is proportional to one of the variables. And this will turn it into what's often known as a bubble plot. And so now in the code below, let me put this onto a couple of lines. Let's just add it and show what it looks like. We've added this size keyword argument So we're making the size of the points now is varying according to the magnitude of the value in the population in the millions column. This sizes keyword argument here too just specifies the range of the smallest and highest, the smallest and largest markers on the map. And you can use that to customize how big the bubbles are. And then we use also alpha equals 0.8 adds a little bit of transparency, so it's a little bit easier to visualize the overlapping markers. So now we have 4 variables are actually being visualized in this one 2-dimensional plot. Okay, if there's no questions about what we've covered so far, the next concept we're going to talk about is facets. So in our previous example, we saw how we could take a categorical variable like the region and map it to colors. But another way we might want to visualize it is to actually split our plot into multiple small subplots that are arranged on a grid, and these are known as facets. And so now if we go back, we're going to go back to a slightly simpler version of our plot without the bubble plot, like just using uniformly sized markers just to keep things a bit simpler. So we have our scatter plot, and right now we've colored the points from the different regions. But instead of having them all in the same plot, if we use the call keyword argument and we say split it into columns based on the region variable, then what we get, and it's just taking a minute here. So now we get these small subplots. They're a little bit hard to read. We'll fix that in a moment. But it's actually split each region into its own separate subplot. So with them all squished onto one row, it's hard to read them. So what we'll do is let's add some additional keyword arguments. We're going to do this call wrap, tells it to wrap the columns so you don't have more than 3. So these next 2 will wrap onto the next line. And then we can also use the height keyword argument, which is going to change the height of each of these small subplots. And we'll give that a minute to run. My computer seems to be quite slow at the moment. It's trying to do too many things at once. Here we go. So now we have our data split into the different regions, each on its own subplot, and it only contains the data points for that region. So now that we've split it into these subplots, we can add another dimension because we're just using everything was all in the uniform color in the previous plot. So now let's add another dimension, and we're going to use the hue keyword argument again. And so now we can actually see not only the region, but also the income group. And so these points are colored, and we have a legend here showing which income group each of the countries belongs to. Now you might notice that the income group values here are not in the order that we would like. It goes low, upper middle, lower middle, and high, and we would probably want it to be low, lower middle, upper middle, and high. So there's a keyword argument hue order, which we can use to make sure to explicitly define the order that these categories should go in. So now I've defined a variable here called income order, and I've specified the order for those categories. And then I use hue order equals income order. And that will make sure that they are in the proper order. So now we go from low, lower, middle, upper middle to high. There's also, if you don't want to have to specify the hue order each time, what you could do is actually use a different data type called categorical. You could convert this income group column in your data frame to a categorical data type and specify the order that the category should appear in, and then it will automatically propagate through all your plots. We won't do that here, but you can follow the link to learn how to do that. All right, and so now we'll see how so far we've just been visualizing the raw values in our data frame, like the data points for each country and each country in a single year. But with Seaborn, we can actually create plots which do some statistical transformations behind the scenes, and they calculate new values and plot those without us having to do the calculations ourselves. So now if we go back to the original world data frame, which contained the data for all the years, and remember how we used, at the end of the last lesson, we learned how to do grouping and aggregation to calculate, for example, the total world population in each year. We used the group by method, and we took the sum. With Pandas, we can actually, instead of having to calculate this ourselves, we can use statistical transformation that's built right into some of the plotting functions. So in this case, if we want to visualize the world population over time, we're going to create a line plot instead of a scatter plot, which is well suited to showing variables changing over time. And so let's do this below. We have the code. We're using the same function, rel plot. We're specifying the data frame. Now it's world instead of world 2015. We're saying to use the year on the x axis, the population in millions on the y-axis. This time we're doing a line plot. This estimator equals sum is saying, because in each year we're going to have many different data points for one corresponding to each country. It's saying take the sum of all of those, and then ci equals none is just to turn off the default behavior. Will give some confidence intervals shading on this plot, and we don't want that in this case, so we just turn that off. So using rel plot and a very similar syntax to our earlier scatter plots, we can actually do these transformations in the background and visualize the aggregated data. And so this shows world population from about 2.5 billion going up to more than 7 billion over these years. So if we want to add even more information to our plot, now we can split it into groups. Instead of taking the total world population, we can take the subtotals within each income group. And so in this case, what we do is we say hue equals income group, and we're specifying the hue order again, as we did before. If we also set the style equal to income group, what that does is just change the line style as in addition to the color, which makes them a little bit easier to visually differentiate them. And we're using the same estimator equals sum and no confidence interval. So what this is doing is it's actually grouping by year and income group and calculating the totals for each of those groups. And so now we have the total population in the low income group, lower middle, lower middle is this one, and so on. And so we can, we're doing quite powerful statistical calculations in the background just by simply changing a few keyword arguments. And then if we want to get even fancier, we can add some facets. And let me, oops, split this on two. Okay, so what I did here is I took our previous plot and now we've added this call equals region, which is going to split it into the facets by region. And again, we'll wrap them and we'll adjust the height. So now this has been, the aggregation behind the scenes is grouping the data into year, income group, and region, and calculating the total population with each of those subgroups. So we have so for example, in Asia, these are the total populations within each income group specific to Asia, and then in Europe, Africa, and so on. Oops. Okay, so we have another exercise to work on. So let's take about 5 minutes for that. And then what's coming next? Okay, I'm probably going to skip. Yeah, where there's a couple sections we're going to skip, and then we'll do the Plotly section will be very quick, just more of a demo than anything else. So let's work on this exercise. Will take about 5 minutes, and then we'll go over the solutions together. Okay, so since we're running short on time, let's go over the solution now, and then we'll do the last little bit. So I'm going to use our previous code here as a starting point. And now we want to plot life expectancy instead of the population. So I'll change the Y value here. And instead of aggregating with this sum, I'm going to change the estimator to mean. And let's run this and see what the plot looks like. All right, so now we have the plot of life expectancy over time in these various income groups for each region. Yes, in the bonus, so we can see this, there's this weird, looks like an outlier here. So, and the bonus asks you to think about if there's ways you could investigate that using the techniques that we've learned so far. So we won't have time to go over that, but in the notes online, there's a link to the solutions for all these exercises. So you can give it a try first yourself and think about it. And then if you want to see my suggestions for that, you can check out the solutions. And just a note about the solutions. So those are, oftentimes there might be many different solutions that will work for a question. So the solutions that I posted are just my solutions, but you might have a slightly different way or different syntax that you've used that will get you to the same result. So just keep that in mind when you're looking at the solution set. Okay, so far we've focused on relational plots. I had a quick slide about categorical plots, but because we're running out of time, I'll just skip that, but you can check that out later if you want. And then we don't have time to get into distributions at all, but it's all there on the Seaborn tutorials if you want to learn how to do distribution plots. And let me just skip these sections. So for the last few minutes here, we're going to just do a really quick demo with Plotly and show how all the concepts that we've been learning so far with Seaborn translate very nicely into Plotly. And we're using a specific package within Plotly called Plotly Express. And so the way Seaborn is a high-level interface to Matplotlib, Plotly Express is a high-level interface to Plotly, and it uses, you can do things like semantic mapping and facets, many of the same things as you do in Seaborn. So to start out, we need to import the Plotly Express library, and we give it the nickname PX. And now what we can do is recreate one of our previous scatter plots, and let me give this a second to run here. And you can see that this syntax is very similar. So now we're plotting life expectancy versus GDP per capita. We have a logarithmic X scale. It's a bubble chart with the points are all sized according to the population. They're colored by the region. And then the big difference you'll notice as I hover over it is that it's interactive. So I can actually, each data point here, I can look at it and see, for example, here is Asia, country is China, and I can see the life expectancy, population, and so on. So this is a really cool thing with Plotly. And the syntax that we use to do this, to create this, is very similar. There are some slight differences, like for example, instead of data, it's called data frame. Instead of hue, it's called color, but they're using this, it's all the same concepts. With just this one command and specifying some keyword arguments, we can create this really cool plot. The other thing you can do with Plotly is zoom in and out. So if I want to zoom in, I can, there's a toolbar here at the top. So I can actually sorry, let me just reset that for a second. I can, if I want to zoom in on a certain area, for example, let's say I want to zoom in on this section of the plot. Now it adjusts the axes so I can see these individuals. So that was actually the United States there, Germany, and I can zoom in on specific regions in the plot. If I click the little home icon, it'll reset. So this is really, really cool. So I've recently started using Plotly and I really love it. We can also use Plotly to create facet plots. Oops, sorry, hold on. Where is this? Category orders. There we go. So now we're recreating one of our earlier plots where we split it into subplots based on the region, and then we do the coloring with the income groups. And again, we can use the same methods where we specify the order for the income groups, and each of these points here, you can hover over, get the data, zoom in, zoom out. So it's basically an interactive version of the plot that we created previously. And now another very cool thing with Plotly is we can add a variable as an animation frame. So now, instead of just looking at the 2015 data, I'm giving it the full data set in this world data frame that has all the years. And I am saying use the year as an animation frame. So what I can do now is I can click the play icon, and it gives a very cool animation over time. And you'll notice on the bottom here, it shows the year as you play the animation, so you can see the year changing. I can also pause if I want with the start and stop buttons, and I can click on a specific year. So 1965, you'll see the year changes here. Let's say I want to look at 2010 and so on. So we've been able to add yet another variable in our data, all of this still in a two-dimensional plot by using the animation as well as the other semantic mappings. So Plotly Express is really cool. You can do, it has a wide variety of plots that you can create. So it's great for purposes where you really want to explore and zoom in and see what the data points are, and you want to have that interactivity. If you're doing more like advanced statistical plots or some of the less commonly used types of plots, then Seaborn, it has a wider variety of plots to choose from. So in that case, you might want to go with Seaborns, but they each have their own strengths. And what else? Yep. So that's basically everything. We have a few minutes left. So maybe if anybody has any final questions we want to go over, or if you wanted to unmute yourself and say hi or share any final thoughts or anything, feel free.
I have a question.
Yes.
So when we create these visualizations, how do we share the information?
That's a great question. So you can, there's a bunch of different ways. And we didn't have time to cover it here, but so you can share your entire Jupyter notebook if you want, so if you use GitHub and you have your notebook on GitHub or upload it anywhere else, there's a website called Notebook Viewer, and I have a link to that in the notes to where, like in the beginning of the first lesson. That's one way. If you just want the plots themselves, you can save them, like for example, as a PNG, or the Plotly files, you can save them as HTML. And so those, you would need to look in the documentation will tell you how to save, but you can, so any of the plot, you can save an individual plot to share that, or, you know, paste it in a report or something like that, or a slideshow, or you can share your entire Jupyter notebook. Does that make sense?
Thank you.
Any other questions or anything? We can finish a few minutes early. This is unheard of. I never finish early. So if you, I'm still around if you have any other questions, but we can just wrap up there. Yeah, it looks like people are pretty much ready to go. So I'll stick around for a little while. Feel free to ask me questions, but otherwise, thank you so much for attending. And thank you to Lisa and all the other helpers for helping everybody out. And yeah, I hope you had a lot of fun and are feeling inspired to use Python and Pandas and make cool graphs.